Example 5. Using x equals 2, find the remaining zeros of x cubed minus 6x squared plus 12x minus 8 equals 0 and identify their multiplicity. So in this problem, we're starting with x equals 2 because when we graph that x cubed equation, we can go to the table and we see that when x is 2, the y value is 0. Meaning x equals 2 is where it crosses the x-axis. It's one of the three numbers of where it crosses. And I know that there's 3 because this is a degree 3 function. And that degree directly relates to how many zeros you have. So this problem is setting me up by giving me one of them and I need to find the other 2. How I'm going to use that number is I'm actually going to divide. So 2 is going to go in my box. I'm going to write out my coefficients of the polynomial. So 1, -6, 12, and -8. I'm going to carry down the 1 and going through the synthetic division process. 1 times 2 is 2. -6 plus 2 is -4. -4 times 2 is -8. 12 plus -8 is 4. 4 times 2 is 8. And I get a remainder of 0. And that should happen every time. So when you're doing these problems where we start with a value that we know it crosses the x-axis, we should always get a remainder of 0. So now what we've done is we've done a little bit of division, and we're left with this function of x squared minus 4x plus 4. Because we had something that was cubic, and we divided it by a linear binomial. Because remember, like when we were talking about synthetic division, x equaling 2 is corresponding to the binomial of x minus 2. Because the number we write in the box is always opposite sign of what it says in the problem. So x minus 2 means we write a positive 2 in our box. So what we've done is we've taken this cubic function and we've divided it by x minus 2, and we get this answer of x squared minus 4x plus 4. So I want you to think for a moment, and yes, I know we're going aside from the problem, but I want you to think for a moment, if I gave us 5 divided by 10, we all know that that's 2, right? So that means if I take my answer from the division and I multiply it by the 5, the thing I originally divided into, that equals my original number of 10. Because multiplication and division are inverses. So if I take 10 and divide it by 5 and I get 2, that means 2 times 5 equals 10. I'm going to use that same concept to finish up the rest of this problem. So that means if I divided this cubic by x minus 2 and I got x squared minus 4x plus 4, if I take the x squared minus 4x plus 4 and I multiply it by x minus 2, that gets me the original x cubed minus 6x squared plus 12x minus 8. In the same way that 2 times 5 would give me 10. Now the purpose of this is not to multiply these together because that would undo all the work that we just did. But the purpose is we're trying to factor x cubed minus 6x squared plus 12x minus 8. And we're going to use division to factor. We couldn't use any of our other factoring methods like factor by grouping because it just simply doesn't work with this problem. So we use division to help us with our factoring. Now we have x squared minus 4x plus 4. The numbers that multiply to 4 but combine to -4 are -2 and -2. And then the x minus 2 carries down. So notice we had x squared minus 4x plus 4, but that factored into x minus 2 times x minus 2. Keeping in mind that we're trying to solve for x, so this is all technically equal to 0 like it was in the original problem. Well, if I have x minus 2 and I solve it for x, that's going to give me x equals a positive 2. All three of these will actually give me x equals a positive 2. What that means is we only have one unique answer, and it's x equals 2, but it has a multiplicity of 3. That's why when you graph this equation, or if you were to, you see that it only crosses the x-axis at one point, but at that one point, it has a multiplicity of 3. So it's counting 3 times.